everyone, this is NetMaven. Today we're going to talk about again Nexus Dashboard Fabric Controller NDFC, which offers the network management system and supports the traditional or multi-tenant LAN SAN fabric on a single window. So Cisco NDFC will do work across all Cisco Nexus MDS switches families, and it manages large number of devices who are providing ready-to-use control, management, automation capabilities, includes virtual extensible LAN, VXLAN you guys love, and we have to do some automation for the Cisco LAN fabric Nexus. It supports the most important automatic configuration for multi-tenant automation, and it does some storage, virtualization, provisioning, and troubleshooting for intuitive multi-fabric topology views for LAN fabric and storage. So what is VXLAN? VXLAN is an overlay technology. Just take a look at this. For network virtualization, VXLAN provides a layer 2 extension over a shared layer 3 underlay infrastructure network by using a MAC address in IP UDP tunnel encapsulation. What I see here are tunnels. So the purpose of obtaining a layer 2 extension in overlay network is to overcome the limitations of physical server racks and geographical location boundaries to achieve a flexibility for workload placement within a data center or different data centers. The initial IETF VXLAN standard, we take it as RFC 7348, defines a multicast-based flood and alarm VXLAN without a control plane. It relies on a data-based flood and alarm behavior for remote VXLAN tunnel endpoints. We call it VTAP. Here, the VTAP peer discovery and a remote endpoint learning is done by VXLAN multicast. So the overlay broadcast unknown unicast and multicast traffic is encapsulated into multicast VXLAN packets and transported to remote VTAP switches through underlay multicast forwarding. We have underlay multicast forwarding right here. And flooding is such deployment can present a challenge for scalability of solution, requirements to enable multicast capability in underlay network. Also present a challenge, right? I don't want to enable like multicast in my underlay. This is because some organizations don't want to enable multicast in a data center or WAN networks. So to overcome the limitations of flooded LAN, VXLAN as defined as RFC 7348, the organizations that can use multi-protocol border gateway protocol, the MP, BGP, EVPN, Ethernet virtual private network as control plane for VXLAN. The IETF would define MP, BGP, EVPN as the standard-based control plane for VXLAN overlays. So the MP, BGP, EVPN control plane will provide the protocol-based VTAP peer discovery and end-host reachability information distribution that allows more scalable VXLAN overlay network designs suitable for private or public clouds. So the MP, BGP, EVPN control plane introduced a set of features that reduces the eliminates traffic flooding in overlay network and enables the optimal forwarding for both east, west, and northwest traffic. The VXLAN EVPN MP sites featured is also a solution to interconnect the two BGP-based EVPN sized fabric in a scalable fashion over IP-only network. This is the lab we'll have to accomplish. The border gateway here is a node that interacts with nodes within a site, and with the nodes that are external to other sites. For example, in a leaf spine data center fabric, it can be a leaf, spine, or a separate device acting as a gateway to interconnect the sites. In this lab, we use Nexus dashboards. Fabric controller is a NDFC sits in here, and we have a Greenfield that's showcase how to provision a new VXLAN EVPN fabric. We'll import and deploy the VXLAN EVPN fabric on a Greenfield and we'll create a brand new logical interface. In this case, this will be the VPC interface from my side 1 leaf 1 and side 1 leaf 2. It will be forming a VPC pair. And the border leaf switch we have here is side 1 border leaf 1 is in place to provision external layer 3 connectivity. We're gonna to use the VRF light, and we're extending the classic Ethernet network to a VXLAN EVPN fabric, including or migrated the 2-hop gateway, which in turn facilitate moving the workloads from the old network to a new network. On the right side is the brownfield. It's gonna showcase how to migrate existing the VXLAN BGP EVPN fabric to Cisco NDFC. So the transition involves migrating existing network configuration to NDFC. Typically, I create and manage my fabric using the menu where down menu CLI configure all these brownfield sites. Now I can manage the fabric through NDFC in a GUI. After migration, a fabric controller will manage the fabric underlay and overlay networks. We import and deploy the brownfields into the NDFC. We remove the bulk creation of the network and VRF, also in this lab. Then we'll have to create a core fabric. Core fabric is to configure the multi-site. A multi-site fabric container will be created to manage the multiple member fabrics. It is a single point of control for definition of overlay network and VRF that a member fabric will share all of this. This is a core fabric. And in the end, we'll be configuring a EPL. What is EPL? Stands for Endpoint Locator. Allows the real-time tracking of endpoints within a data center. So the tracking includes tracking the network life history of endpoints and getting insights into trends that are associated with endpoint additions, removal, move, and deletion, and so forth. So the endpoint is anything in the IP or MAC address. In that sense, the endpoint can be a it can be a virtual machine, it can be a container, or it can be a bare metal server, or it can be a service appliance, anything. So that's it. That's it all about this lab. We'll have to do it now. Before we do that, I have NDFC. I will tell you it has two interfaces. The adapter 0 and the adapter 1. Adapter 0 will be sitting at the management interface 198.18.133.100. This is how we log on to it. Adapter 1 is gonna be IP 198.18.4.101 and is used for the EPL. My NDFC will take care of VXLAN EVPN fabric on my Greenfield. We have to import and deploy the VXLAN EVPN fabric. We import a clean fabric and configure VXLAN BGP EVPN inside one, and we have to clear all configurations on the switches except the management before pushing VXLAN EVPN configs on the switches. So this is the first day 0 steps in the NDFC, and the life cycle management is my Greenfield fabric. To create a fabric is a Greenfield fabric where I define the fabric settings such as we have defined the BGP AS number, and we'll have to replicate the modes for bomb traffic. The bomb represents for broadcast, unknown unicast, and multicast. We have to deploy an underlay IGP, and we'll have to make a subnet, make a field subnet for the underlay, and we have to define the VTAP. We talk about this VTAP interface. VTAP represents for virtual tunnel endpoints, denotes. So, and we have to define other settings also. I have to achieve the configuration of the fabric using a powerful, flexible, and customizable. We use the template framework, and with minimal user input, I can bring up the entire fabric with Cisco recommended best practice and configuration in a short time period. The set of parameters exposed when creating a fabric in the fabric settings allows me to tailor the fabric to my preferred underlay provision options. The first task is to create a fabric. We have to open my fabric controller. Then let's navigate to Manager and the Fabric. Log on to Manager Fabric. We're gonna add one more fabric. On the Fabric controller, let's create a fabric. We're gonna create a site 1. Greenfield. Choose fabric. Find out the Datacenter VXLAN EVPN fabric. We're going to create the fabric site 1, and AS number we'll use 51111. All right. 65111. Underlay mask will pick a 31. We're gonna go to replication, find out a replication, underlay RP, loopback ID, make it 251, and go to advanced tab, Then we're going to scroll down to Greenfield cleanup option. Here, we want to say enable because we're creating a Greenfield fabric, and when preserved configuration showing is no. Okay, and go up and click resources. Here is where we define our resources. We'll have to go down, scroll down to VRF light deployment. Here we want to use back-to-back to external. That is the back-to-back to external via VRF light. Okay. Find out auto deploy for peers. Want to deploy to the peers also. So when I select this option, NDFC can automate the configuration on an external device if it's like the NX OS, or it's gonna be ASR 9K. Okay, we will configure via VXLAN for the external network device also. So it's all over VXLAN. It's all over VXLAN. Alright, then after everything, we'll click save. Let's add switches. Is also a day zero life cycle for Greenfield fabric in the NDFC, which is to discover and import switches that make up the fabric. The switch discovery and import process are going to be done by using a seed IP of the switch in the fabric. This option is what I use for lab and is applicable for both the Greenfield and Brownfield. Okay. In a closed fabric, each switch in an equal distance from each other. So a switch in my fabric is selected, and the NDFC lets me to define an expected hop count to reach other switches in my fabric for discovery. This discovery occurs when giving me access to a switch through a local admin using local admin user, or a AAA user can log into it. If it's set up in the fabric settings, the user must be able to SSH to the switches, perform an SNMP v3 queries, and run the show commands. One of the show commands is for CDP to discover subsequently directly connect switches, not to exceed the specific hop count during the discovery. So we'll have to add a switch. So let's double click the side one Greenfield. On the switches, we'll have to add a switch. So the switch we're gonna add is IP 198.18.4101. It's my seed IP of switch. So admin say Cisco password. We're going to uncheck preserving config. We don't want to use the existing config. Unchecking will clean up configure on the switches. That's what we want to do. So let's discover the switch. Click confirm. And discovery process will start in a minute. And to discover everything, let's check everything. But we're going to deselect the switch of external device, external router. We don't want to discover this and add it into my side one Greenfield fabric. As well be external L3 fabric. In the later, I'm going to tell you. Click add a switch. So this process will add all the switches. So when my switches are added to my Site 1 Greenfield fabric, the next day zero task is to ensure each switch has assumed to correct role in the fabric. Importance of the roles defines the how and what the best practice configuration templates that I use to deploy a configuration to switches in the fabric. So as part of building automation of discovery and import, the system automatically assigns default roles to based on the switch model. So if we have a 9300 Nexus, it's going to be assigned to a default role to leave. And if you have Nexus 9500, you're going to assign to the spine role. So in production VXLAN EVPN, fabric list default roles are correct for most of the switches in the fabric. The switches that assume the roles of a border leaf switches or border gateway leaf switches, for example, must have their role correctly. So these might be a different role for border gateway. For the border leaf, there might be a different role they will have to assign to specifically. So my role Site 1 Greenfield fabric has a border. We're going to have a border leaf, and border gateway. We're gonna have Site 1 gateway 1 needs to perspective role assigned to the border gateway 1 and border leaf 1. So we'll have to wait the switches to be added. It's still taking place. I pause my video till this process is complete. Let's close it. Find out the switches were all added. We're gonna tap in Site 1 gateway 1 and we're going to assign a role, set a role as the border gateway. Select that. OK. Now we'll find the Site 1 S1, Site 1 S2, and we'll set a role to spine. Select spine, click OK. And the Site 1 leave 1, Site 1 leave 2 are already leave role, and we'll click Site 1 leave Site 1 and border leave 1, and we're going to set a role to a border. Alright, the role assigned, they are all done. Like Site 1 gateway 1 is assigned to border gateway, border leaf is border, I have leaf, I have spines. So now we're going to configure access interface to the server. Access configure to the server, Ethernet 1/5, 1/7, and a 1/5 on leaf 2. So all we have to do is go to interfaces. Under future, we're going to type interface equals Ethernet 1/5. Click enter. Now we're going to find the Site 1 leaf 1 and Site 1 leaf 2, both on the Ethernet 1/5. We'll have to assign. Then we'll click what it is, Site 1 leaf 1, Site 1 leaf 2, and click edit. On the policy, first thing we're going to do is to make sure it has the correct policy, which is interface access host policy. When selecting it, and we're going to click save and next to change the policy on the leave, second leave switch. Same thing, choose this and save. Click deploy. and to do some configuration preview. We're going to find out expected config. Then when we view the config, we have to deploy it. Here's how many lines we have to configure, and what's current, what's pending we have to add, and deploy the config to the interfaces. Is showing deploying. That's what we expected. Right, the two configurations has been deployed. We can now configure my VPC pairing. So the asked day 0 task I performed for my Site 1 Greenfield fabric is to make my Site 1 Leaf 1 and Site 1 Leaf 2 a VPC pair. A VPC pair is right here, and say the classic way a VPC will have to say VPC domain, right? The peer link, the keep alive peer link, and the member port. All right. So when if not already open, we go back to NDFC. We have to go to fabric and check in the fabric. We'll have to go back to switches. Okay, let's tap Site 1 Leaf 1. We'll have to make a pair to it. That's VPC pairing. VPC pairing pop up. We're going to locate the Site 1 Leaf 2. We'll click its corresponding checkbox, and at the bottom here we'll click save. We'll make a pair. Okay. So the Site 1 Leaf 2 shows as a set to true and only recommended switch capable of being a peer because it is connected to Site 1 Leaf 1. So when I receive a warning, I just check OK, that's OK. And at the top here, action, we're gonna to recalculate and deploy. Mind your steps, okay? Do this. The action buttons on the top, it shows blue. Click it and recalculate and deploy. Now everything will be pushed to all of the switches. It applies to the global, not global, the fabric is wide switches. You see a lot of out of sync. Every single control switches are showing of the lines to be deployed. We'll have to deploy it. Deploy all. And this is gonna take time. Pause my video and till all the command lines are executed. The next task is to configure the VRF and overlay a tenancy in VXLAN EVPN needs a layer 3 VNI for symmetric IRB if I need to use inter VXLAN routing. So a L3 VNI is associated with a tenant VRF routing instance that is separates the routing domain between the tenant and overlays. It is one of the powerful things about the NDFC. It automates and provides a health check that all VRF, BGP, EVPN, VXLAN configuration is correct. This can be one of the configuration to handling a large production environments with many peers and many tenants overlays. So this app, I created the stage and stage the first tenant, overlay VRF, and associate 3 VNI. I'll go through workflow and create networks that include L2, VNIs, and VLANs, and associate them to an overlay tenant VRF. What all I have to do, go back to the fabric, we're going to click the VRF, we're going to create VRF. VRF create is going to be a blue VRF. Use the default VRF ID 50,000 And the proposed VLAN, we're going to propose the 2000. The templates will have to use the default. Extension templates will use the default. And VRF name, I'm going to say blue VRF, blue VRF, blue VRF also. Everything blue VRF. Then click the create. So in here, we're already create a called a blue VRF VRF ID 50,000. Okay, we'll create this. Next, we'll create a network. The NDFC are the network in the NDFC are where I define layer 2 VNIs associated to VLAN for layer 2 segments or bridge domains over the route fabric. The L2 VNI enforces segmentation by not allowing the layer 2 traffic to traverse the VNI boundary. If I need an inter-VNI or VXLAN routing, the L3 VNI VRF is required. So if needed, a switch with SVI or VLAN interface called any cast gateway exists on all leaves that I configure and are associated to L3 VNI VRF. I do not need to route between the L2 VNIs. Then L2 VNI can be layer 2 only. So in this demo, I define 2 networks for inter VXLAN routing that are associated to the L3 VNI VRF I created in previous step. So this is gonna be my L3 VNI. Under it, I'm going to create 2 L2 VNI. So let's go to network or create. One is called Blue Net 1. L2 only. I don't want to be an L2 only, right? So network ID or preferred is 30,000, and VLAN ID will propose it. It maps to 2300. Okay, go down here. We give it a gateway that's gonna be 192. The one is 68.1.1/24, and the VLAN name Blue Net 1. Blue Net 1. So this is all we have to create. One is called Blue Net 1. The VN ID shows as 30,000. That's one of network. (11.1/24). Okay, click create. Now let's create a second Blue Net 2. VNID 30,001. Okay, propose a VLAN 2301. What is in here? VLAN 2300. We have to make the information here so you all know what I'm doing. 92.12.1, so 24. Blue Net 2. Blue Net 2. Blue Net 2. 30,000. 1.12.1 is the gateway. VLAN 23.01. All right, we'll create L2 VNI, L3 VNI VRF. Let's create. Here you go. That's all we have to create. Now we have to make attachments. In NDFC, VRF network attachments can happen independently. So I create VRFs and attach them to leaf switches, then create a network and attach them to the leaf switches. I can combine the workflow where I create the VRF and associate network to the VRF, and finally we'll deploy the networks to which deploy the VRF, and in this all adhering to Cisco best practice. So I have staged my overlay tenant VRF and staged the two host networks that's associated to my overlay tenant VRF in the previous step that I just created. So this is now time that we're going to attach these constructs to the leaf switches that required it. So this requirement comes based on the design of how hosts and the EXSI connect to my leaf switches. There are two standalone Linux instances. In Linux instances that are connected to my leaf 1 and leaf 2 on both E/5. This is the interface that I use policy to configure and access the interface, leaving the access VLAN undefined. Other parts of the attachment workflow is to select the interfaces for the network that I deployed, whether it's access or a chunk. I already made an access. So for this lab, I will select the E/5 interface. So between my two leaf switches for network, I first created. So to do that, we will go to the blue net 1 network attachment. And we find out the side 1 leaf 1. We'll click edit and we'll make attach to E/5 leaf side 1 leaf 1. Click save. Let's close this. Double click BlueNet 2. Network attachments. Find out side 1 leaf 2. Add it. Find out the switch interface. Side 1 leaf 2. Click save. Close this. So what I've done, I attach Ethernet 1/5 to the BlueNet 1 and side 1 leaf 2 E/15 to the BlueNet 2. Okay. Now it's showing pending. I would to configure. It's time to deploy. At the top right action, calculate and deploy. I'm seeing 86 lines to be configured. Here you go. Click deploy all. Close it after deployment. Now showing deploys in two networks. So when performing the action to deploy network attachment, the intent is for my VRF to deploy at the same time, because the VRF association with the network, when I create it or confirm the VRF, here is showing deployed also. Let's now verify Site 1 fabric. We log on to the CLI through the NDFC. I have created and deployed my Site 1 Greenfield VXLAN EVPN. I'll perform a level of verification by checking the deployment status of NDFC reports. Now I'm going to connect some of the devices in my Site 1 fabric to issue some show command and to verify configuration NDFC deployed by the NDFC. So also we're going to use the Linux servers that are connected to Site 1 leaf 1 and Site 1 leaf 2. So 1 and 2, I'll perform the data pan verification. We'll check connectivity to my Anycast gateway, and I will check the inter VXLAN routing between my two servers. Log on to leaf 1. We're going to show IP/OSPF neighbor. So the leaf 1 has 3 neighbor, IP/OSPF neighbor as expected. We're going to open my spine 1. Here I have 4 neighbors. Show BGP L2 VPN EVPN summary. I have EVPN neighbor also. Back to the leaf 1. I show VPC. It shows peer status are okay. Peer keyboard link is alive. Show MVE VNI. I have 2 L2 VNI and 1 L3 VNI, which is the blue VRF, blue net 1 and blue net 2. That's verified the Site 1 data panel. The 2 Linux servers are connected to my Site 1 leaf 1 on the Ethernet 1/5 and the Site 1 Ethernet 1 leaf 2 1/5 respectively. I will use this to test the inter VXLAN data panel connectivity within the same tenant over the VRF in my Site 1 fabric. We're going to ping from the server 1 to server 1 to server 2. Now let's return to my fabric controller and I'll go back to this Site 1 Greenfield, and under close this, we'll have to go back to topology. Topology is under the overview. We're going to double click the Site 1 Greenfield. I'm going to click the change to configuration. Showing out of sync. It's okay, we'll fix it later.
Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below. Hey Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below.